Hi students, this is Ms. Medina, and in this video we're going to talk about symmetry of functions. There's going to be three particular symmetries that we're going to address, and that is when a function has, or when a relation has a symmetry over the x-axis, over the y-axis, and over the origin, or a particular point, okay? So these particular points, the x-axis, the y-axis, and the origin, that's the symmetry that we're interested in this standard. All right, x-axis symmetry, if you can see the mouse moving right there, is when a graph is symmetric with respect to the x-axis. That means every point on the blue graph has a corresponding point on the red graph, where the only difference is that the y value has the opposite sign. All right, so the a's are going to be the same, but the b's are going to be different. Visually, when you look at it, we think of it as the x-axis is acting like it's like the top is a mirror image of the bottom, right? Literally, if you fold across the x-axis, the top portion would be completely over the bottom portion, okay? But this is not a function, because if we do a vertical line test, you would see how this vertical line would touch the red line and the blue line at the same time, and that disqualifies it as a function. In nature, we see this mirror image over a horizontal line, and this is what we mean by having x-axis symmetry, okay? The top portion could overlap the bottom portion, and you can see it in both of these beautiful pictures. Not a function. Y-axis symmetry is when you can fold across the y-axis and everything on one side would completely overlap everything on the other side, okay? Every point has a counterpart. The only difference is that the x-axis would be going in the opposite direction, right? Starting at the origin here, you notice that this point AB is 2 to the right, 2 up, whereas this one is 2 to the left and then 2 up. Right? Other than that, you can think of it as the y-axis being the folding line, and it would completely overlap. Now you'll see this type of symmetry in many different places, and these particular functions that have symmetry across the y-axis are also called even functions. And the last symmetry that we're interested in is symmetry across the over the origin, or 0, 0. When you get to geometry, this is also going to be called rotational symmetry. This is a 180 turn, and the point of rotation is going to be the origin. Okay? Right now, we're just going to call it symmetry over the origin, with respect to the origin. And you can think of this like the graph is going to look the same upside down or right side up. Right, literally the same. So if you look at this blue line right here, and if we flip it upside down, you still have the blue line right there, okay? Watch this animation, how this is going to rotate. You see? Even if I flip it upside down, it would still be the same graph. We call these functions odd functions. So I would expect you to remember that for x-axis symmetry, right, it's folding from the top to the bottom, or horizontal folding over the x-axis, and it's not a function. Y-axis is vertical folding over the y-axis, and they're called even functions. And symmetry over the origin is literally when you look the same way whether you're upside down or right side up, and we're called odd functions.